Hello my dear students, this is P. Venkateshwarlu, PGT Physics. Yesterday, means in previous video, we have already discussed about in gravitation, so that gravitational potential energy and gravitational potential. Okay, so now we are going to discuss about escape speed. Escape speed. Escape speed. It is denoted V suffix E. V suffix E. Okay, see here. We can project a body through upwards. Okay, what happened? Yes, after some height reaches by the object will return towards the earth surface. Okay, understand? See here, in this case, gravity will act on the body to regain its original position, means to become same position, means due to the gravity. Okay, see here, the thing is we can project or we can send an object away from the earth surface. It should not be once again towards the earth surface. Okay, so it will not return. Okay, see that amount of velocity needed to escape from the earth gravity. Okay, so coming to our content, escape speed or escape velocity, the minimum velocity of a body or satellite which is escaped from the earth gravity is called escape speed or escape velocity. Once again, the minimum speed or velocity of an object with which the body moves away from the earth surface with some velocity which is avoid the earth gravity to bring from towards the earth surface is called escape speed or escape velocity. Simply, the minimum velocity is required to escape from the earth gravity is called escape speed or escape velocity. Coming to the derivation, what is the derivation for escape speed or escape velocity? Okay, see here, in this case we have to take that velocity, kinetic energy we have to take. Kinetic energy which is equal to gravitational potential energy. Gravitational potential energy. Understand? So we have to take magnitude. So 1 by 2 mve square is equal to kinetic energy. A body gets kinetic energy by virtue of its motion. 1 by 2 mv square. Okay. Understand? Gravitational potential energy means G m by r. Okay, understand? We have to take positive gravitational potential energy. Okay, understand? Now m gets cancelled, then ve square is equal to 2 into gm by r. Okay, ve is equal to root of 2 gm by r. Okay, here we have to do multiply with r and division with r. Okay, after that we can get the expression v is equal to root of 2 gm by r square into r. Okay, so instead of gm by r square, in previous expression we can get small g is equal to gm by r square. Okay, rearrange this equation, we have to get 2 into small g into r. Okay, this is the expression for escape speed or escape velocity. Okay, what is the definition, my children? The minimum speed is required to escape from the earth gravity is called escape speed or escape velocity. In this case, the gravitational potential is equal to kinetic energy. Understand? So both are equal means the body will not come to the earth surface. Okay, so we know the kinetic energy formula and the gravitational potential energy. Be careful, this is gravitational potential energy from the previous expression. Okay, we have to take here magnitude, means positive value. Okay, by using this, by cancelling m and m, we can get V square is equal to 2 into gm by r. So we can applying to both sides, we can get like this expression. By multiplying r into r by r, we can get the expression like this. We know that in previous condition, acceleration due to gravity, which is small g is equal to gm by r square. Okay, so finally we can get VE, escape speed or escape velocity, root of 2gr. Okay, so we know that g is equal to 9.8 meter per second square and r is equal to 6400 kilometers or 6.4 into 10 power 6 meters. We can substitute these values in this equation. We have to get 11.2 kilometer per second. Kilometer per second, my dear children. Okay, per second 11.2 kilometers the body moves. Okay, so the minimum speed or minimum velocity which is a body escaped from the earth gravity is 11.2 kilometer per second. Next, my dear children, orbital speed or orbital velocity. Orbital speed or orbital velocity. Orbital velocity or orbital speed. Okay, what is orbit? What is orbit? Okay, see here we know that according to Bohr's postulates. Okay, so nuclei is there. Every atom consists of nuclei. So this is atom. This is nuclei. Around the nuclei, electrons are revolved in circular path. Okay, understand? So electrons are revolved in particular path. Okay, particular path is there. That path is called orbit. Understand? So orbit is a particular path which is in circular shape, in which the electrons are revolved, or in which electrons are moving along the orbit. Okay, understand? So coming to our orbital velocity. Okay, see, while discussing this orbital velocity, we have to take object, that is satellite. Okay, what is satellite? What is satellite, my children? Satellite is an object which is revolved around the planets like moon or earth. Okay, in a particular orbit. For the purpose of using this satellites signal, transmitting data from one place to another place, capturing of these images, videos from the earth surface. Okay, mainly we can use satellites for communication purpose. Okay, any object or satellites which are revolved around the earth or other planets, so with a particular orbit. Okay, so which needs some speed or velocity. That velocity is called orbital velocity. So once again, orbital velocity, which is defined as the velocity, the minimum velocity of a object or satellite which is moves in a particular orbit, or which is revolved around the planet in a particular orbit, is called orbital velocity. Okay, so in this case, so while a satellite or any object which is revolved around the nuclei or this particular earth or moon, okay, understand? So in this case, two forces are acting on the body or satellite, which is so centripetal force and centrifugal force. Centripetal force and centrifugal force. Centripetal force means towards the center, and centrifugal force means away from the center. Okay, understand? See here, suppose this is Earth. Earth. So around the Earth, we know that moon revolves. Okay, understand? Here moon is, we can consider natural satellite. Okay, so moon is natural satellite which is revolved around the sun in particular orbit and particular time frame. Understand? In this case, so two forces are acting, Fc and Fg. Understand? If both forces are acting equally, so then the body revolves in a particular orbit. Okay, otherwise the body may move tangentially, moves away or towards the sun. Maximum the moon with no force of centripetal and centrifugal, the body moves tangentially like this. Understand? Okay, in this case, so what is centripetal force and what is centrifugal force? Centripetal force which gives mv0 squared by r. Okay, understand? Then centrifugal force which gives gravitational force. Okay, understand what's that? Gm by r square. Okay, from equation 1 and from equation 2. Okay, please remember, my children, these formulas. Centripetal force in previous means 2D motion. Okay, now by equating 1 and 2, we can get mv0 square by r, which is equal to gm by r square. Okay, understand? Here r gets cancelled, only one r is there, m gets cancelled. By rearranging this, we can get v0 square is equal to gm by r. Okay, so we can multiply r by r. So finally we can get v0 square is equal to gm by r square into r. Okay, v0 is equal to root of gm by r square into r. Okay, we know that g is equal to gm by r square. We can substitute g value g root of g into r. Okay, understand? So orbital velocity or orbital speed v0 is equal to root of gr, medicine. Okay, understand? Root of gr. Okay, what is orbital speed or orbital velocity? The minimum velocity or the minimum speed of a satellite or object around any planet. Okay, which is revolved around the particular planet with some speed. That speed is called orbital speed or orbital velocity. Now, relation between orbital velocity and escape velocity. Relation between orbital velocity and escape velocity. From the previous expression, orbital velocity is equal to root of gr. So again, escape velocity is equal to root of 2gr. From escape velocity, we have to write root 2 into root gr. Okay, so root 2 into root of gr, we can get v0. Okay, finally we can give the expression, the relation between escape velocity and orbital velocity. Escape velocity root 2 times of orbital velocity. So now this is the expression of the relation between escape velocity and orbital velocity. Energy of orbiting satellite. Okay, my children, energy of an orbiting satellite. Okay, we know that energy means the ability to do work. Okay, so orbit means we know that in around the nucleus, around the sun and around the earth, some satellites are moves in a circular path in a particular path. That path is called orbit. Okay, understand? So we know that satellite means satellite which is defined as objects. Satellite means which are objects which revolved around particular planets in a particular path. Okay, that path we can say orbits or orbitals. Means orbital means in chemistry you have to take. So now here in this case we have two types of satellites. So what are the satellites? Natural satellites and artificial satellites. Example for natural satellites which are moon. Okay, so here moon is revolve around the earth. Okay, understand? So now artificial satellite means man-made. Okay, for the purpose of communication and transferring signals from one place to another place. Okay, so many artificial satellite is there. InSat 1B like that. Okay, so for the purpose of gaining some pictures from the earth surface, still have not seen from the surface. Okay, so now here how we can calculate the energy of orbiting satellite. Okay, see here. So while satellites are natural or artificial satellite revolve around the planets like Earth or Moon, okay, which having two types of energy: kinetic energy, potential energy. Okay, so if we can get both kinetic and potential, we can get the total energy. Understand? Total energy. First one, potential energy. Potential energy. What is potential energy? Potential energy, which is defined as by the configuration of your body, gets it potential energy. So we know that the general expression for potential energy is mgh. Here we have to take, instead of potential energy, gravitational potential energy. Gravitational potential energy. We know that the gravitational potential energy means what, my children? The minimum amount of work done bringing a body from infinite distance to a point in the gravitational field. So that work we can say gravitational potential. So what is the expression? Yes, my children, minus g m by r. Okay, g is the universal gravitational constant, m is the mass of the earth, small m is the mass of the body, r is the radius of the earth. Okay, so next kinetic energy, my children. Kinetic energy. Kinetic energy, which is equal to 1 by 2 mv square. mv square. Understand? So a body gets kinetic energy by virtue of its motion. By virtue of its motion, my children. Okay. So now here in this case we have to take that orbital velocity. Orbital velocity. Okay, v0 we have to take. So 1 by 2 m, what is v0, my children? What is v0? v0 is equal to root of gr. Okay, v0 is equal to root of gm by r square into r. Okay, understand? R square into r. So r gets cancelled. We can get v0 is equal to root of gm by r. Then v0 square is equal to gm by r. Okay, understand? So 1 by 2 m. What is v0 square? gm by r. gm by r. Understand, my children? Please remember it. Please remember it, my children. Understand? Now, so the expression for kinetic energy Ke is equal to 1 by 2 gm m by r. Okay, understand? This is equation 1, this is equation 2. Then how we can find total energy? Total energy, it is denoted TE. Okay, so what is total energy? The sum of the potential and kinetic energy is called total energy, my dear children. Okay, understand? The sum of the potential and kinetic energy is called total energy. So now total energy which is equal to, so what is the sum of kinetic and potential energy? Yes. So potential energy minus G m by R plus kinetic energy G m by 2R minus m. Okay, TE is equal to, see here, G m by R. Okay, in both we can take common. So G m by R. Remaining here we can get minus 1. Here plus 1 by 2. Okay, rearrange this, my dear children. Rearrange this. So minus 1 plus 1 by 2. Minus 2 plus 1 by 2. Minus 1 by 2. Okay, understand? Minus 1 by 2. Gm by R into minus 1 by 2. Rearrange this. Total energy which is equal to minus Gm by 2R. Understand, my children? So energy of an orbiting satellite, gravitational potential energy, we know that derivation, minus Gm small m by R. Then kinetic energy from this expression with the help of orbital velocity, we have to get 1 by 2 Gm by R. Okay, then total energy, the sum of the potential kinetic energy is called total energy, which is after calculation we can get T is equal to minus Gm by 2R. Gm by 2R. Okay, my dear children. So now this is the total energy. Kinetic energy is there, potential energy is there. So what is the ratio? Ratio of kinetic and potential energy. Okay, so what is the ratio? Ratio, very very important. Ratio of kinetic energy, potential energy, total energy. Kinetic energy, potential energy, total energy. So what is the kinetic energy? Yes, 1 by 2 Gm by R. What is potential energy? Minus Gm by R. Total energy? Minus Gm by 2R. Okay, understand? Very very important, my dear children. So they asked ratio in previous NEET. Okay, Gm by R gets cancelled. We can get 1 by 2 is to minus 1 is to minus 1 by 2. Okay, understand? So multiplying with the 2 into 2 gets cancelled. Okay, finally 1 is to minus 2 is to minus 1. Okay, understand, my children? Be careful. By taking kinetic energy is to potential energy is to total energy, we can take the formulas, we can cancel the common part, we can get 1 by 2 minus 1 by 2, multiplying 2 we can get the ratio 1 is to minus 2 is to minus 1. Understand? Which is very very important. Okay, so this is yes, the ratio is kinetic energy, potential energy, total energy. What is the ratio? 1 is to minus 2 is to minus 1. So if any competitive exam, if they given potential energy, we want to find kinetic energy means, okay, potential energy is equal to 2 times of minus 2 times of kinetic energy, like that. By using that we have to find. Okay, understand? So this relation is applicable for an electron revolved around the nuclei in particular orbit. For that electron, kinetic, potential and total energy ratio. Okay, understand my children? This is useful for both cases. For electron, for satellite which is orbiting around the sun and around the planet, and electron for electron which is revolved around the nuclei. Okay, my children?